In this video, you're going to be introduced to standardized mortality ratios. We're going to start by covering standardization more generally, why we do it. Then we're going to go through the basics of calculating a standardized mortality ratio, and then finally we're going to figure out how to interpret them. Standardized mortality ratios fall under a broader topic of standardization, which is something that epidemiologists use all the time. I pulled a recent article just to show you a recent example of standardization being used. This particular article focuses on the prevalence of doctor-diagnosed arthritis and arthritis attributable activity limitations between 2010 and 2012. It's publicly available on the internet. And the data that they analyze in this study is from the National Health Interview Survey. Now I'm going to call attention to a phrase that's asterisked in the table description, age adjusted. And then you go down to what it's referencing, and it says age adjusted to the 2000 U.S. projected adult population using 3 age groups. Then if you look within the table, you can see that there are columns for unadjusted and adjusted values. For example, the unadjusted prevalence of doctor-diagnosed arthritis is 22.7%, and the adjusted prevalence of doctor-diagnosed arthritis in the adult population is 21.4%. While the National Health Interview Survey is meant to be nationally representative, the sampling is not perfect. And in this case, the adults sampled in the National Health Interview Survey were a little bit older on average than the adults in the U.S. population in 2000. And we'd expect to see a little bit more arthritis in a group that's a little bit older. So the authors accounted for this discrepancy by standardizing the prevalence estimates to the U.S. population's age distribution. The thinking being that the adjusted prevalence estimate is closer to the true value. Okay, so let's see how this works in practice and see how it relates to standardized mortality ratios. Now we know that welders are at risk of breathing in a lot of nasty stuff on the job. And we know that breathing in certain chemical compounds increases the likelihood that somebody's going to get lung cancer. So as a bunch of budding occupational epidemiologists, we might want to compare the lung cancer mortality rates among a group of welders with rates in the community. For those of you who have been exposed to the issues of confounding and effect modification, let's just put those aside for the time being and assume that higher rates among welders are in some way, or at least could be in some way, due to occupational exposures. If you just look at the rate in the community and compare it to the rate in the welders, they look pretty similar, and you might come to the conclusion that the rates are the same. And if you chose to stop there, you might then conclude that welding doesn't appear to be associated with an increased risk of lung cancer, and that breathing in welding fumes is pretty benign. Now let's see what happens with standardization. We'll start by focusing on these values, the rates. These rates are reported in the number of deaths for every 1,000 person years. Person years are a tool that epidemiologists use to estimate exposure. Following 1,000 people over the course of 1 year results in 1,000 person years. Following 500 people over the course of 2 years results in 1,000 person years. Following 2,000 people over the course of 6 months results in 1,000 person years. I think you get the point. Starting with 18 to 44-year-olds in the community, we saw that over the course of a year, 1 person in that age group died. Out of 1,000 people at risk of dying of lung cancer in the middle of the year. To calculate the rate, you divide the number of deaths by the mid-year population and multiply by 1,000. Then to calculate the rates for welders, you do the same thing in that population. Next, we're going to take the values from this table and reorganize them in a different table. We're going to start by taking the mid-year population of welders and stick it over into this column. Then we take the number of deaths that we observed among the welders and transfer it to this column, observed number of welder deaths. Then we're going to take the age group specific rates of lung cancer in the community and stick them into this column. And by setting up this table, we're going to seek to answer how many deaths would we expect among the welders if welders had the same age group specific rates of lung cancer as members of the community. So we multiply the mid-year population of welders by the rate in the community per 1,000 person years, and we get the number of expected welder deaths based on the community's lung cancer mortality rates. Now you might notice that just by looking at the expected number of welder deaths versus the observed number of welder deaths, that they're not equal. Now, taking a look at this table, you might notice that over here in the left-hand column, we have the number of deaths, the observed versus the expected number of deaths, which is what we just calculated. Now, both the observed and the expected number of deaths resulted from 1,000 person-years of exposure, which allows us to calculate an observed and expected rate of 7 and 3.5 respectively. We can then take those observed and expected rates and plug them into the formula for the standardized mortality ratio. And when we do that, we see that the standardized mortality ratio is 2. So what does this mean? This means that the observed mortality rate was 2 times higher than what we would expect if welders had the same lung cancer mortality risk as members of the community. We were a little bit fooled initially when we saw that the rates were relatively equal between the community and the welders, because the community was a little bit older on average than the population of welders that we study. And because lung cancer becomes more common as people age, it looked like people in the community were at the same risk of lung cancer mortality as welders. So it appears that there might be some occupational exposures that these welders are breathing in that increase their risk of lung cancer relative to that of the community. But, and this is a big but, the standardized mortality ratio here is dependent entirely upon the community that we select as the reference group. Most of the criticisms of the standardized mortality ratio as a measure in occupational epidemiology relate to whether the worker group and the community group or the reference group are actually comparable. For instance, the welders might differ from the community in other ways, including socioeconomic status and smoking rates. Depending on how the data was collected and organized, it may not be possible to account for those differences statistically. So, regardless, the bottom line is that standardized mortality ratios have a reputation for being prone to bias. So be careful if you come across one.